Okay, today in IM2 we're going to talk about proving triangle similarity with angle-angle, the angle-angle similarity theorem. Okay, so some people will call it the AAA. You don't need to do that because of the triangle sum theorem, right? So if we already have proved that two sets of triangles are congruent, we know by the triangle sum theorem that the third one is. So it's only angle-angle, okay? All right, so here's a proof of the angle-angle similarity theorem. I'm going to leave that to you. It is in your book, and you can study it there. So go through each step and understand it before you go on, okay? Okay, so we're going to use the triangle similarity theorem to determine whether these triangles are similar. And then if they are, write a similarity statement. Now, what's important for you to remember is when you're writing your triangle similarity statement is that the corresponding parts have to be in the same position, just like they were when you wrote a congruency statement. So we'll look at that when we get to that point, if these are congruent. So the first thing I can say is that angle D is congruent to angle G because all right angles are congruent. Okay? Then we're going to use the triangle sum theorem, and we're going to say angle E, I'm trying to find my missing angle E plus 26 plus 90 equals 180. Okay, so this equals 116, so I'm going to subtract that from both sides, and I get angle E equals 64 degrees. So then I look up here and I say, oh, angle H equals 64. So now I can say angle E is congruent to angle H, and now I've got two angles. So I'm going to write my similarity statement, okay? Now, remember, corresponding parts. So I know that D corresponds to G, so I'm just going to go ahead and write those first. Then I know that E, and when we're using a triangle, there's only three sides, so we don't have to worry so much. But if you were trying to do a polygon with more than three sides, then you would want to make sure that you're doing consecutive sides or angles, okay? So this is E and H, and then the last side is C and K. Then we put similar by A. Now, one other thing that they gave you a hint in the book is using color coding to color code your angles might be helpful when you're trying to figure out which pieces are the corresponding pieces. So it can't hurt. Okay, so in this one, they want you to determine whether the angles are similar. So I want you to go ahead and press pause if you want to, and take a couple minutes to check these out and see if they are similar. Okay, so what I did was I found that these two angles are congruent. So angle A is congruent to angle E. And then I found the missing angle here. So I said 15 plus 90 plus C equals 180. So angle C equals 75. And then I looked over here, and so I saw that angle C is congruent to angle D, so I can write my similarity statement. So ACB is similar to, and look at the ones that are corresponding, EDF. Okay? Now you could have gone ABC equals DEF, but you want to make sure that you've got them in the same position. Okay, so let's check these out. So we have an angle that's equal. So we're going to find the missing angle here. So angle E plus 44 plus 30 equals 180. And so angle E equals 106. And so we can see that that does not equal this. So therefore, angle DEF is not similar to, triangle DEF is not similar to triangle ABC. Okay? All right. And this is not a real symbol that you would use. I'm just telling you that the answer is no. Okay, so there you go. Okay? All right, so how would you prove similarity for number 3? So, one thing that you want to notice is what information are they giving us here? Okay? So you could do this a couple of different ways. If you use the parallel lines, you could say corresponding angles are congruent. And you're done. You've got angle, angle. So angle, that would be triangle ACE is similar to triangle BCD. Okay? That would be one way. Another angle that you could use is angle C if you used reflexive property, because it's part of both of them. And so you could use that one as well with one of the other ones. So there's lots of ways that you could prove this one. Okay? You can see that I've marked them all. And I did this one first, but you could also do the corresponding angles one. So don't be afraid to look at things from multiple directions. Okay, so here's another one for you to think about. So look at the diagram first and get all the information that you can from it. So the first thing I notice is that opposite sides are parallel. So this is a parallelogram. Okay, so what information does that give you? Well, there's a couple different things. I could use the parallelogram opposite angle theorem to prove that angle P is congruent to angle R. Okay, so I could prove these congruent right away. Or I could just think of these as parallel lines cut by a transversal. And then I've got this angle equals this angle, and this angle equals this angle. So I've just proved all 3 angles, and I only needed 2. So you can go about this any way that you want, but the important thing is we have just proved that these 2 triangles are congruent, or similar, I mean, not congruent. And there is the write-up. Okay, so there's our triangle similarity statement. Notice P over here and R are in the same position. Okay, so be careful with that. Okay, and just because they're the same letter doesn't mean they go in the same position. Okay, we're talking about PQR, that's this angle, and it's congruent to RSQ. Okay, so Q and S are in the same position. So you've got to be really careful. Okay, so here is your exit ticket. Now, I'm going to use these numbers on the exit ticket, so you don't have to worry about figuring out what numbers they are. So it'll say, number 5, find the measure of angle AGB. So just use these numbers so there's little confusion. And I took these out of your journal, so you can work them out there and put your answers on the slide. Take care.